Hi there, Pre-Calc gang. Time for another lesson in Chapter 7 on verifying trig identities. This is by far the toughest part of this chapter and a big focus on it. So we'll give you some background info today and show you a couple of examples, and then when we get to class we'll really work hard on this stuff. So the idea when we verify an identity, again remember an identity is an equation, but it's true for every value of x or every value of theta. So when we verify them, this is akin to saying this is our proving of identities. We want to get the left side to look like the right side, so it should be a mirror image of each other. I'm not sure if this is a great example, but basically that's all we're trying to do, is get the left side to look like the right side. So here's some strategies that we're going to do. Generally we'll work on the more complicated side, and we'll try to break that down and simplify that. We are going to substitute and simplify, so all those identities that we looked at in Lesson 7.2, we'll be employing those here. We want to generally, this isn't always true, but most of the time we want to express all trig functions in terms of sine and cosine. It's a little bit easier to simplify them when we do that. Won't be true in every case, and even in one of the examples we look at today, maybe not the most efficient way, but generally that's a good plan. And here's the key thing that you have to fight against. Those of you that are used to solving equations, we're used to adding something on each side of an equation or multiplying each side of an equation by something. We don't want to do that here. We want to just work on one side at a time. Oftentimes we'll be able to work just on that most complicated side, trying to simplify that. We won't even have to do anything on the other side. But sometimes these problems involve working on one side or the other side, but not crossing over. Alright, so that's kind of the basis. Let's actually tackle a couple of examples here. So here's our first one. We are going to try to verify that this is an identity. And again, we're not trying to solve anything. All we're trying to show is that this right side looks like the left side. So we're going to heed one of our other strategies, which was to work on the more complicated side. Clearly that's the right side here. Now, do we have any simplifying that we can do here? I've got to change my thickness here of my pen just a second. And I think I do. Cotangent, 1 over tangent, or another way to write it is cosine over sine. That's just my numerator there. Meanwhile, cosecant, we might remember that is 1 over sine. Now that looks pretty messy, but a nice thing will happen here. Remember that when we divide fractions, it's like multiplying by the reciprocal. So it really becomes cosine over sine times the reciprocal of my denominator, which will be sine over 1. And sure enough, if we look what happens here, my sines will cancel out. And so what I have left then is simply the cosine of x on the right side. And sure enough, look at what I had on the left. That's also the cosine of x. And so then we will give our very triumphant check mark here to show that we're done with this. Remember, as long as you show that the left side is the same as the right side, you are done. You will have proved or verified that particular identity. Alright, let's go on to 1 plus tangent squared over cosecant times secant equals tangent. Now clearly the left side is the more yucky side here, so let's see what we could do with that. Now most of the time we said see if you can write these in terms of sine or cosine. Maybe an exception here. You may recall, if you look at our first day of notes on 7.1, that 1 plus tangent squared, that's actually part of a special identity. And in fact, that particular identity is that 1 plus tangent squared, maybe even jot it over to the side here, that 1 plus tangent squared equals secant squared. So that's what I'm going to substitute in there right away in place of that 1 plus tangent squared. So it's going to be secant squared over cosecant secant. Remember, I'm not doing anything with that right side at all yet at the moment. Now, how do you know when you can cancel things out? That's always a point of contention, it seems like, with pre-calc students. Well, everything is multiplied and divided here, so I can actually cancel out one of these secants. And so then what I'll have is 1 secant, so I'll have the secant of x over cosecant of x. Now, you might remember that secant is 1 over cosine. Here's where I do want to employ my sines and cosines here. And in the denominator then, cosecant is 1 over sine. Running out of room here a little bit. And sure enough, here's where I want to employ my multiplying by reciprocal idea. Dividing is the same as multiplying by the reciprocal. And sure enough, when I do this, I get sine over cosine. And of course, another name for sine over cosine is tangent. So on the left side, I do all this work. I kind of ran out of room. And I end up with, I'm going to change colors here so you can see what I end up with here. On the left side, I ended up with tangent of x. Of course, on the right side, I also have the tangent of x. So once again, I'm done. I make my famous little check mark here to show that I'm done, and I have verified this identity. So tough stuff, but the more familiar you are with these trig identities, especially ones that you can substitute, the better off you're going to be here. And even though these are challenging problems, there's a great sense of accomplishment when you're able to do problems such as this. All right, thanks for watching, everybody. We'll be plugging away at this stuff in class, so we'll see you then.